So this is really fun. This is the first one of these I've actually done, so you guys get to see all my new slides. I think they're pretty good. And so I'm here to talk about Magic. Magic is a universal network. And the idea is that you can programmatically get access to connectivity anywhere in the world. So who am I? Just quick background. Why would you listen to me about this? So I've been involved in tech for the past decade or so. I've launched startups on 3 continents, and most recently, I serve as the CEO of Hologram, which is a telecommunications provider for IoT. We give you one SIM card that works anywhere in the world on over 550 networks worldwide, automatic carrier switching, fun stuff like that. And so at Hologram, we thought a lot about how you connect machines to the internet. And we've started to come up with this idea that really what you need is something that allows you to connect any device to any network anywhere. And this is what Magic is designed to do. It's designed to take these things that are sort of human-centered, where you need actual contracts with like a large provider, and make it so with just a bit of code, you can actually hop onto a network that's cellular, hop onto a network that's Wi-Fi, even potentially satellite, things like that. And so when we think about this, we think about it in the context of the evolution kind of the internet from Web 1, where you have this like very centralized sort of structure, to Web 2.0, where you have things distributed in the cloud, and now into Web 3, where you have just complete decentralization and complete decentralized apps. And so the people who are more blockchain focused in the audience will understand this as basically rather than having something that's sitting in a server somewhere, you have many servers all around the world trustlessly running the same sort of protocol. So if we apply this to connectivity, we think about connectivity 1.0, which is essentially you just go to a major carrier to get a contract. And this works fine for your cell phone bill, but for machines, they can't go and engage in contracts with carriers. Also, you're frequently going to have situations where the carrier isn't going to give you good access to networks. There's going to be issues with roaming or heavy steering towards a given network. And if you have an application like autonomous driving that really needs top-notch coverage, then you're going to need to be able to hop between networks. So we've thought about connectivity 2.0, and this is essentially unifying these networks into something where you can actually roam between multiple networks that are most performant, in a smart way. And then Magic is designed to be connectivity 3.0. It's spectrum agnostic. It basically unifies all of these siloed networks, whether that's private or public Wi-Fi, overlapping cell towers, into one thing that you can just gain access to. And so overall, connectivity 1.0 doesn't work for IoT. So we've just talked about that a little bit. I mean, generally speaking, you can do it, but you're going to have a lot of problems, especially as you try to scale across multiple countries, things like that. And what we've done at Hologram is kind of like connectivity 2.0, but there's some shortcomings to it, right? Like, as it's cellular only, you have all this wasted spectrum. You have people who are constantly building overlapping Wi-Fi networks that you can't tap into. And so now we got this nice blob that kind of shows you that Magic is designed to be this fluid network. And what you get with that is a single global connectivity resource. And what that means in kind of more tangible terms is you could imagine a world where you don't actually think about having a cell phone bill, or you don't actually think about having an ISP. You just kind of have access to networks constantly. In the background, it might be AT&T's backhaul, it might be Comcast backhaul, it might be someone who's running their own ISP, but you can still get that. You can still get that connectivity in a fluid fashion without major contracts. And so you end up with this sort of connectivity marketplace, which is super fluid. It's autonomous and trustless, so you don't actually need to know the person you're transacting with in order to make this happen. It means it's not human-centered, but code-centered. And as a result, it's hyper-available and programmatically accessible, which, especially for IoT use cases, is super useful. You can imagine an autonomous car driving down the street, just querying networks and procuring data, paying for it with micropayments, things like that. So this is all kind of like a big idea, right? But how does this actually work? So right now, I'll just walk through some quick definitions. So to start, when we think about the network, we think about providers and consumers. Providers on the network are people who are broadcasting connectivity. Consumers are consuming that connectivity that providers broadcast. You can have people who are both providers and consumers on the network. They can be people who are big or small. You could be running one of these things out of your window, or you could be a major telco who's actually providing connectivity to a large swath of people. In order to make this work in a trustless way, we provide two novel proofs, and then the concept of identity. So we use a proof of availability that allows you to kind of add different access points to the map, and a proof of transport, which essentially allows you to provably say that bandwidth was sent from one place to another. And this is necessary if you're going to transact with someone and basically pay them for connectivity. Today, when you pay your cell phone provider, you kind of just trust what they tell you, right? You're like, oh, I must have used 100 megabytes or 2 gigs. But this would allow you to basically prove that, yes, I actually did pass X amount of data through a pipe. So the proof of transport, if we visualize it, it looks like this. It's fairly straightforward in that we basically just have a client and network. Client begins connections to the server, and then you're able to just connect in. Networks provide offers and say, hey, this is actually how much I'm willing to give you for connectivity. If you're running like a free Wi-Fi node, say out of like a coffee shop, the price can be 0. And actually using the global ID setup that we have, which is just kind of taking that public-private key pair inherent in cryptocurrency and making it your authentication mechanism, you can actually just walk into a hotspot, a Wi-Fi or a coffee shop and connect to their free Wi-Fi without a captive portal and do so securely. Client accepts the offer, and then, yeah, hooray, transmitted data, connect commences. And then you check in every so often to make sure that the network is still working, and you might disconnect, and you might move between different nodes. And so we can do an on-chain settlement, which means that we can actually just transact directly on the blockchain for the cost of that connectivity. You pay in a native protocol token, which would be magic tokens, basically. Or you can do an off-chain settlement, which is if you connect to a bunch of different hotspots, you might do some sort of mechanism that allows you to just do micropayments to each one of them. The proof of availability, this is also probably relatively intuitive, I would hope. It's basically, you just put up nodes, and then we verify that they're real, and we have some mechanisms to do that. And then once we verify they're real, you actually get paid just for providing new nodes. Over time, as the network grows, we haven't actually, of the things that we have to define are exactly how these rewards work. But over time, as the network grows, right, creating a new node isn't that interesting because there's density. But at the start, you might get rewarded just for putting up a node in somewhere that people need connectivity. And then at a deeper level, as this starts to take shape, we end up in a situation where we think about provider incentives and kind of creating an efficient network. And this is where we talk about like spectral efficiency or building a network around the needs of people who are querying it. So we might, for example, say, hey, there's population here versus there's higher population in the city versus in this small town. So we're going to incentivize nodes in a certain way. There might be an algorithm that allows you to do that. You have coverage requests, so it actually turns out that we know from people that they want connectivity right at this building. And so as a result, you might get more rewards for putting up a node there. And then we think about areas without coverage and just saying, hey, we want to generally have as close to 100% coverage density as possible. I think that there are a lot of good things that already work in connectivity, but one of the challenges can be rural areas with dead zones, underserved communities. And this is actually, it's not just important for like a social reason, but when you think about smart ag or mining, things like that, oil and gas, oftentimes it's really difficult to get coverage in these places. So it'd be great, we think, if you could incentivize people to create those networks. And then I'll just provide a quick note on privacy, but you can check out our website and some of our materials if you want to dig a little deeper into this. Or talk to Pat, our CTO, right there after this. So the way that we think about this is we're not innovating on the privacy access, but we do want to provide a experience that when you're using Magic and connecting, it's going to be as safe or better than using a VPN. And we'll do this by building a privacy enabler role into the network. And so if, for those of you who are kind of more crypto oriented, there's a concept called token curated registries, which is essentially where people vote for things that are legitimate, and they stake their money to say, "This, I believe this VPN provider is a good VPN provider." We're experimenting with the idea of using that to have a curated list of VPN providers who would be compensated for providing VPN services. There are some other projects out there that are seeking to do distributed or decentralized VPNs, and we generally view them as complementary to our project. So like Orchid Protocol is one that's out there, and we would love to like overlay that on top of Magic, for example. And then the end result, right, is why would you use this, right? So you end up in a scenario where you have no captive portals, you have a super resilient and redundant network, ideally cheaper access to data costs because you have a more efficient marketplace for providing connectivity, and you have sort of end-to-end encryption, and you can do smart congestion management as part of this. So you could, if you're at a concert and the cellular isn't working, you can actually offload in an intelligent way to Wi-Fi and do so without having to negotiate a captive portal or anything like that. So use cases, I'll walk through a couple that are just sort of, that I've touched on a little bit, and then go into some IoT specific ones because we're at an IoT meetup. So shared Wi-Fi is a super obvious one where you just walk into a place that's already sharing Wi-Fi and you get a better, faster Wi-Fi connection. We think about on-demand roaming. This is especially for people who are traveling. So you show up in a new country and you need access to a network. You don't want to buy a SIM card, whatever it is. You can actually just hop on a network wherever you are worldwide. Efficient congestion management is one I talked about a little bit. So by, right now, right, in this block, there's probably hundreds of Wi-Fi networks running, but they're all siloed. You can't access any of them. So even if the cell towers are crammed up, you can't get on any of this like available spectrum. So by being more spectral efficient and allowing for some of these siloed networks to actually be accessible, we can improve congestion management. And then this concept of incentivizing new network rollout, I think, is especially interesting. So you can think about this in terms of Wi-Fi in places that are not just a coffee shop or your house. You can also think about it in terms of 5G rollouts. So, right now, in order to roll out 5G, you have to, there's a mixture of small cells and large cells. Small cells need to be placed like every 50 meters. And you're going to end up with like telephone poles with like a bunch of equipment on them. And it's a huge, huge thing. So we think there's an opportunity either for large telcos or through the use of unlicensed spectrum to actually roll 5G in sort of a collective decentralized manner. And provide incentives for people to do that. And the result, right, is that you could have something very, very cool like a Bluetooth relay. So this is a Tile Bluetooth device. And the Tile Bluetooth device, right now, they sort of have this thing where, connect back to your phone. And presumably, if there's other people with Tile app, maybe it can connect to their phones. But if you lose your luggage and it's halfway across the world, you're kind of screwed, right? Like your Bluetooth won't work in that scenario. However, using something like Magic, which is radio agnostic, just as long as you have the actual Bluetooth chip or Wi-Fi chip or cell chip, you might be able to have a scenario where a Tile can actually phone home by hopping onto someone else's device via Bluetooth. So it makes Bluetooth this sort of thing where, it makes technologies like Bluetooth a thing where you can actually get access to an internet backbone in a way easier fashion, and improves what you can do with that type of technology. You think about sensors as well. So sensors, there's a lot of talk, I think, about, and this is probably relevant to timescale as well, a lot of talk about this idea of taking small amounts of sensor data and selling it into a marketplace and being able to break that off and monetize it. In order to do that, right, like you need these things to actually be able to have connectivity as well. And so rather than having some really expensive or big cell phone plan, you might just have the ability for this thing to pay in small micropayments for connectivity, just on an as-needed basis. So you might even be able to sell your data into a distributed marketplace and also pay for data in the same transaction. Maybe you're even ending up in a scenario where the data offsets the cost of connectivity. So I think this is a really exciting kind of world when you think about all these types of autonomous things that just need access to the internet, but based on the current technology cannot connect to the internet without human-centered interaction. And I think my favorite one is the autonomous vehicles use case. So we see this a lot firsthand at Hologram. Right now it works. And people are happy to use cellular for this, but you could imagine a world, right, where there's a lot of cars that all need network access, and you can end up in a scenario now where rather than having to, have 3 SIM cards for redundant network access, or use something like Hologram that gives you redundant network access, you actually just programmatically have the car querying different networks. So as it's driving down the street, it's hopping from shared Wi-Fi to coffee shop Wi-Fi to cellular, back to shared Wi-Fi. And I think this is sort of, if you kind of imagine this like multiplexed future where you have like a many-to-many relationship in terms of devices and what they're actually doing in the world. I think this is a really good tangible one and a good example of what you can accomplish with something like Magic. Cool. So this is just the summary at the end, I guess. Today, fences separate each networks. You have this inconsistent and opaque service quality. You can run like a speed test, but ultimately it's not auditable to know exactly how much data you transacted, exactly how fast it was transacted, things like that, or was delivered, things like that. Spectrum inefficient. You frequently also have unencrypted communications. So Wi-Fi coffee shops are super insecure. Even stuff where you think it's kind of encrypted is often not that encrypted. We have a good post on Hacker Noon about that, which I'll throw it somewhere. I don't know. You can just Google Wi-Fi Hacker Noon. It's human-centered. You have to trust third parties, which I think actually is not that big of a deal, but you do end up with a lot of constraints, especially when you start thinking about a world where more and more autonomous things are going to need access to networks. And so Magic reverses all of these, right? You get one universal network, it's transparent, you pay for what you need. Anyone can broadcast and provide a network. I think that's a really, really interesting idea, especially when you think about large players and small players kind of working in tandem, or the idea that you could even start your own ISP. And there's some organizations in New York who have started doing this, like NYC Mesh, for example. And it's decentralized and trustless. So even if you didn't particularly like what I have to say, like Magic will still work. You don't actually have to trust me. That's Magic. And if you're interested in checking it out, you can go to mgc.co/join. We just released a developer alpha, so you can set up a little gateway if you want. You'll need a microtech router to do it. It's still very, very, very early, but would love any and all feedback, and that's kind of why I'm out here doing this stuff. That's Magic. Cool. Am I taking questions? 2 questions? All right.
Okay, questions?
When your car moves from the network to network, how do you know that it's not the car in the middle?
Yeah. Yeah, so how do you prevent like a man-in-the-middle attack? Is that the idea? Yeah. Well, so you could have... The idea with the way that we're setting up the security paradigm is that we'll use something, rather than ambient security, where when you have access, when you hop onto a network, you just you're like in the walled garden, but now everyone kind of has access to what you have. We'll use a paradigm called capabilities-based security, and we'll do that using, especially for Wi-Fi specifically, we'll use WPA2 Enterprise. So whenever you connect to a network, even if it's not a trustworthy network, your connection is still going to be siloed ideally from like service to service. So you can actually connect to networks that are attackers, but because of the encryption and because of the VPN by default and because of the capabilities-based security paradigm, you won't be in a scenario where an attacker can actually intercept your data. What's that?
So is it the same encryption on different networks?
Yeah. So in order to run a Wi-Fi access point, you need a router that supports WPA2 enterprise, and so as a result, you'll have a similar encryption and security paradigm on all of the access points that are available. This is actually one of the challenges in the sense that older routers that don't support WPA2 enterprise can't really run this. And so it's one of the challenges that we face. But that's how you unify the encryption scheme.
How's it going?
Oh, sorry.
Sorry.
I don't know. I guess Lindsay's.
So if in doing like my limited research with hologram, I'm building out a prototype right now, and I was just curious regarding the autonomous car example that you had said. When actually, I guess hologram is looking for the nodes while it's in transit. Is battery consumption like a problem? Like if the hologram is connected to like a gateway, and how do you guys deal with that?
Yeah, so I think the question, and correct me if I'm wrong, is essentially, are there battery issues with sort of roaming between networks? So what's happening is, so this will be a application specific thing. Hologram SIM will talk back to a hologram access point, and you'll end up in a scenario where you can access multiple networks, and the device will kind of choose how it accesses those networks, but it's not like constantly scanning and wasting battery life doing so. Cool. Is that it?
Yep. Well, we'll answer more questions at the end of the Q&A.
Cool.
The end of the fireside chat.
Yeah, and I'll be around. So if you want to stop by after and ask me a question, and you can email me as well. It's ben@magic.co. Thanks so much.